going to talk a little bit about a cloud native adventure where I'm doing a quick appetizer turn. We're going to have a bunch of plates for various projects. Now, my name is Ralph Squillace. I'm a program manager on the Azure App Platform Upstream team, and I spend most of my time working with projects that are cloud native lifestyles. That, of course, revolves around Kubernetes and Docker and things like that. I am the PM for the VS Code, Kubernetes Extension, CNAB, and a bunch of other projects. We'll talk about some of those really quickly. But in this case, I want to really sort of highlight a whole bunch of categories of projects, some of which we have helped start, and many of which we did not and are invested in heavily because we think they're very important to know about as you move from certain kinds of ways of doing business into the Kubernetes ecosystem and a cloud native lifestyle. And so this is going to go really quick, so I'll do my best, but throw all the questions into the chat. So let's start, shall we? One of the interesting things about this is that if you actually look at the landscape of the CNCF, you can immediately think maybe you should hit the backspace. It's real easy to do. So what we want to do instead of doing a tour is actually hit kind of a highlight of areas that we see as critical for moving forward and understanding. One of those is Helm, which is the package manager for Kubernetes, really. There are many other ways of distributing. For example, Helm is super popular, super useful. It's been around almost as long as Kubernetes itself. Because when we've done the CNCF surveys for the last couple of years, about 70% of all the respondents say that their deployments are using Helm, which is a massive amount of knowledge embedded in YAML, our favorite format. The nice thing about Helm is it just makes it easier to do Kubernetes work and share and deploy and operate units of functionality logically, right? Even though one unit might be 6 or 7 different pods, might have different configurations and values, or the same unit might have different values for a different cluster, right? Helm helps you get that work done. And it's a very easy place to start. So one of the projects that we find critical is Helm. It's really important. How does that work, really? Well, first of all, manifests, if you're familiar with them, they can be very complex. There can be a lot of lines there, and many of which are repetitive. And so the first thing Helm does is manage complexity a little bit. It moves most of the repetitive text out of the way and lets you focus on a few sets of variables that are frequently changed. But the rest of the deployment is a unitary thing, and that makes operations much easier. For example, you can easily update by changing merely one variable, and an upgrade happens, right? You can simply share all of these things as a chart, right? So you can subscribe to certain repositories, pull those down. Those repositories can exist anywhere, in file systems, in other Helm repositories formally, or even on your local machine, for example, for testing or development, whatever it might be. So sharing is critical to Helm charts, and that's a little bit harder to do with floating files and manifests. Finally, because you can do easy updating, you can do easy rollbacks. Now, some people who shall remain nameless don't like the word rollback. They like roll forward into the past. But however you like to talk about it, rollbacks are part of updating, they're part of operations, and Helm allows you to do that by targeting a previous release very easily as a logical entity. So Helm is critically important. Now, most people may have heard of Helm. If you haven't, you need to jump straight into Helm 3, but many people, as you can see, are using Helm. Version 3 is critically important to move to. There's a couple of reasons. First of all, we've had a whole bunch of community experience in the Helm environment, such that V3 makes use of that. So all the Helm charts that have been built and optimized and perfected over those years are available from Helm 3. But it's also a dramatic simplification. Helm has been around since Kubernetes, which means before RBAC was put into Kubernetes, before that was the main security approach for Kubernetes, especially in production environments and not development environments, before custom resource definitions. And now we don't have to have a custom backend for Helm. And the removal of that back end called tiller, which used to have to be secured very properly, right, means that all our security works through the Kubernetes API as it should. So Helm 3 is the place to be. And because operations are a critical aspect of the complexity of Kubernetes, Helm needs to be one of those projects that if you're not into, or if you're worried about moving forward, you really should spend your time doing that. We also invest in something called Brigade. Now, Brigade's a little bit interesting. It's part of the operations world, but it's not specifically about any kind of operation. It's not CI/CD. It's really about using your cluster as a bash environment. You can script containers that already do some work together using a Brigade.js file, a JavaScript that stitches things together and passes state using config maps between each container in what is essentially pipe to bash kind of functionality. It's useful for anything. It can listen on any number of events, including cloud native events, cloud events, that specification, but it can also produce events as well. So it's a generic automation system that all you need is a Kubernetes environment. It's something you should look into. Finally, in this automation sort of operations area, a project that we raised with a bunch of collaborators, including Docker, Pivotal originally, now part of VMware, Datadog, and several others, is a Cloud Native Application Bundle spec. And that's actually like Helm, but to include runtimes that are not Kubernetes. And so while you can deploy a Helm chart in a CNAB bundle, right? You might not often do it if in fact your entire work plane is Kubernetes. You'll use Manifest, you'll use Helm, and the fact that you can use it from other tools is not really that important to you. But sometimes you need a CDN and it's on Cloudflare, or it's going to be Akamai or some other CDN. And in the regular world, we normally kind of script that on top, right? It's not part of the Kubernetes call. It's not part of the operational matrix in that direct way. And so Cloud Native Application Bundle allows you to put all of that work, no matter what the runtime is, no matter what the tooling is that installs it in one Docker container. So it can be shared, it can be executed, it can be even serialized, digitally signed, moved offline, or even air gap scenarios. It's worth looking into. And to build that, you're going to need a tool. The tool we've worked with upstream is called Porter, which is a declarative format to create a CNAB bundle to install and operate your application, even beyond just Kubernetes. It's another tool and a specification that we think is really, really important for operations. Now, if we shift the middleware idea from operations into applications, right? We have this area where it's just above Kubernetes and just below your application, say your function or your service that you've implemented. And that area requires a lot of functionality that if you didn't have something else do it for you, you'd have to learn and do it manually. That area is the area where service meshes are currently residing. And we just heard a conversation about service meshes that give you a lot of details. But it's critical to understand that this interface that lays right in there allows you to have a certain set of basic service mesh functionality. They're tremendous, as Lee and Bridget were talking. It should be clear that that is a great way to start doing networking and basic features at the application level before you, for example, jump below the service mesh interface and take advantage of custom features from some particular service mesh. They have a certain set of functionality already available: access control, specs for per protocol routing, traffic splits, traffic metrics, things like this, that are the core functionality that people are looking for from their service meshes out of the gate. There are many other other features that people are looking for, and you can jump down and consume those custom features underneath the service mesh API. Bridget's right, it is hard to keep the mess out of the mesh when you're doing a presentation here, so I'll do my best. But these are the core functionality, and you'll find more features adding into the service mesh API interface spec area as we go along. And I'm really looking forward to that, like everybody else is. Whoop, I bounced out of my presentation, which is always fun. All right, so another area of what we might call interface stuff So like I say, I love the fact that I just acquired the PowerPoint banner. Yay! The web is fantastic. Is the security middleware. And one of the projects that we think is critically important is Open Policy Agent. Now, Open Policy Agent is a policy-based control plane. And you can run it in Kubernetes, but you can also run it natively on nodes and VMs, and also run locally. You're able to go ahead and take care of all of the work that you need to do by using policy to prevent or allow the kinds of operational work that you think creates confidence in your infrastructure. Open Policy Agent was not created by Microsoft, although we contributed some of the tools that use it in Kubernetes. But we think this is a critical middleware area that is operational, but specifically for your confidence level in your infrastructure and your applications. And it can be used not just on the client side, but on the server side as well. So for pod security policy, Gatekeeper is the project that Microsoft was involved in because we wanted to make sure that the power of Open Policy Agent and Rego policy rules were available in the Kubernetes and namespace. ConfTest can be used to test locally your policies against structured configuration data that you have, so you can be sure that the policy that is going to be used on the server, right, does actually enforce the rules that you think give you confidence in your working environment. For example, you don't necessarily want Ralph, who is a very uncontrolled developer, but full of talent, we will admit, deploying random containers from some public repository that you haven't really had a chance to look at, running alongside potentially sensitive environments. So you want to have something like a rule, a policy statement that prevents him from deploying anything that isn't a container from your private registry, where you understand exactly what can be deployed and has been scanned for security vulnerabilities in various forms. This is critically important. Now, some of the tools are not at the infrastructure level. They're actually at the application level. This is one that I have played a role in, and it is completely open source. It does use the VS Code editor. It is the VS Code Kubernetes extension. It also has an extension API, which means in addition to viewing and managing your clusters visually, so you can click instead of having to figure out which pod name that is and then cutting and pasting and so forth, right? That makes it very easy to do all of your development work against a cluster. But in addition to that, being open source, being able to run on any, it just requires a kube config, so any Kubernetes cluster will work. It is also, it also exposes an extension API. So others, anybody, whether it's another organization or whether it's you as a developer, can create custom experiences that fit into and reuse the base Kubernetes functionality to do all that work as well. Let's see. Another one that we're interested in the application namespace, in application surface is Dapper, the distributed application portable runtime, because it runs anywhere, including any Kubernetes cluster. The critical thing to understand about Dapper is that it attempts to give you runtime functionality inside your programming environment. That is, from your code inside your container. So instead of having to have a bunch of back-off exponential retries to understand that, or instead of having to understand a particular service discovery functionality, and doing all this extra work as an application developer, the Dapper runtime provides that functionality for you in code as an SDK from any language. This is based on connecting to services either with HTTP or with gRPC. So it can be used from any language directly, or you can use an SDK from all the languages that are supported. That's to help developers build microservices effectively and easily inside their code environment. There's another one that we participate in, which we feel is important, called Open Application Model, OAM. Rudder is the Kubernetes implementation of OAM. This one is slightly different than Dapper in that it tries to make sure we understand the dividing line between developers, application operators and infrastructure operators that is evolving in the world that we see in front of us with our customers and in the community. So this one is worth investigating if you want to keep your developers writing application code and have specialized developers and operators focus on their application operations as opposed to infrastructure operations, rather than having a full stack operator or a full-blown SRE model, which is fantastic for those people that can afford it, but might not be fantastic for those people that can't for whatever reason, right? Finally, a couple of things we want to make sure that people know are here. Virtual Cubelet is a CNCF project that creates a Cubelet facade. So instead of the kind of traditional Kubernetes clusters where everything's a fantastic, formal node, we have a virtual node which can be lazily created at any time. This is the underpinning for Microsoft virtual nodes in AKS. But we also have a new kubelet on the block. That's CrustLit, which is the same kind of virtual kubelet, but built for Rust developers so they can use it natively. It also runs web assemblies and not Docker containers, and web runtimes and not containerd. So this can be very, very interesting because it can take advantage of features that WebAssembly has, which is, some people want to know why. And the answer is because actually instead of shipping entire environments, which containers do, you're actually just shipping the binary that does the work. And that's much, much smaller even than containers. Containers were supposed to be very, very small and optimized, but in the real world we're seeing there's not a lot of focus on the optimization of the size of the container compared to what we thought and what would be a best practice. It's super fast startup times. It is cross operating system and cross architecture, and it's helpless by default. It can't do anything. So the security stance is much more rigid. Finally, leading into the next conversation, which I'm really looking forward to, is the cluster API work that's being done that allows you to go ahead and begin to treat all of your clusters at an operational level through a Kubernetes style API and functionality. And I'm very much looking forward to this because developers could create billions of containers as soon as we could automate it. So we created orchestration for that. Now they can create billions of clusters, and we need orchestration for that. The solution for orchestration is Kubernetes. I hope that some of these projects find some interest. They spark something in what you're doing. If so, I want you to go out and join up on one of these projects. All of them in the CNCF or in open governance, and they have channels. Find the leaders to do it, because the real truth is all of us are working for the same team. We just happen to be working for different companies. So join me in doing that. And also follow up on the cluster API talk. It's going to be very, very interesting.